500 years ago, someone shaped a 100-ton stone so precisely it still fits perfectly against the one next to it. No mortar, no iron tools, no wheels. This wall has survived earthquakes that destroyed Spanish colonial buildings built right on top of it. And the wildest part? We're only now starting to understand how they actually did it. How did the Incas cut stones this precisely? To understand how impressive this is, you need to understand who built it. The Inca Empire rose in the early 1400s and, within about 100 years, controlled a stretch of South America over 4,000 kilometers long, from modern-day Colombia down to Chile. That's roughly the distance from London to Baghdad. They built this empire across some of the most brutal terrain on Earth. Steep mountain slopes, thin air, freezing nights, no horses, no oxen, no wheeled carts. Those simply weren't part of their toolkit. And yet scattered across this empire are structures like Sacsayhuamán, Ollantaytambo, and Machu Picchu, stonework so precise that modern masons, when they try to replicate it by hand, often walk away stunned at how long it actually takes. Let's start with the most famous example. Just outside Cusco sits Sacsayhuamán, a massive ceremonial and military complex. Its outer walls are built in a zigzag pattern, made of megalithic limestone blocks. Some estimate it to weigh between 90 and 130 tons. Here's the part that stops people in their tracks. No two stones share the same shape. Each one is irregular, multi-sided, almost sculpted rather than cut, and yet they interlock so tightly that the seams between them are barely visible, even after 5 centuries of earthquakes. This technique is called polygonal masonry, and it's not just about looking impressive, it's structurally brilliant. Because the stones have so many contact points and irregular joints, they're believed to distribute seismic energy differently than a straight, grid-like wall would. During an earthquake, researchers think the stones shift slightly against each other and then settle back into place. A kind of ancient shock absorption. Compare that to the Spanish colonial buildings erected nearby using European stone-cutting methods. Many of those have cracked or partially collapsed in earthquakes over the centuries. The Inca walls beneath them are still standing, so the real question isn't, is this unexplainable? It's how did a civilization without modern tools engineer this level of earthquake resistance into raw stone, hundreds of years before seismology existed as a science? Now let's talk about Ollantaytambo, because this is where the puzzle shifts from how did they cut it to how did they move it. The stones used at Ollantaytambo's temple complex were quarried from a site called Cachicata, across a valley, several kilometers away, and significantly higher up on the opposite mountain. To get multi-ton blocks from the quarry to the construction site, workers would have had to lower them down one mountain, cross a river, and haul them up another. No wheels, no draft animals capable of that kind of load. Llamas can carry maybe 25 to 30 kilograms on their backs, nowhere close to what's needed here. So how? This is where the Incas' real secret weapon comes in, and it's not a lost technology, it's a system called the mita. It was a form of organized labor tax. Combine that manpower with ramps, log rollers, and thick rope made from natural fiber, and you get a plausible and partially tested method for moving these blocks. Smaller-scale experiments have confirmed that ramps and rollers can move stones of this size. What's still being researched is the exact route engineering and logistics the Inca used to pull it off at this scale, across this terrain, without a written planning system as we'd recognize one. Now, the core question. The cutting itself. The Inca didn't have iron or steel tools. What they had were hammerstones, harder rocks like hematite, used to pound and shape softer stone through repeated percussion. It sounds primitive. The results are anything, but archaeologists believe the process worked something like this. A stone was roughly shaped at the quarry, then transported to the site. There, workers would place it against its neighboring stone and slowly, painstakingly pound away material until the two surfaces matched. Essentially test-fitting the blocks over and over, adjusting a few millimeters at a time. This is called an additive trial-and-error method, sculpting by direct comparison rather than measuring with instruments. It's incredibly labor-intensive. Some researchers estimate a single large block could have taken months of continuous work by multiple people. What's still genuinely debated isn't so much how as how consistently. How did a workforce without written blueprints, without metal squares or levels as far as we know, achieve this level of precision across hundreds of structures throughout the empire? Was there a specialized guild of master masons? Some form of standardized training passed down orally, generation to generation? We don't fully know yet. The Inca kept records using knotted cords called quipu, which researchers still haven't fully decoded. So if construction plans existed in some form, we may simply not be able to read them yet. It's tempting to file all this under unsolved ancient mystery and move on. But the real story here is more impressive than any mystery framing could be. This was a civilization without the wheel, without iron, without a written alphabet in the way we understand it, and they engineered structures that have outlasted colonial buildings built with supposedly superior technology. They didn't need our tools because they built their own systems. Organized labor, inherited craftsmanship, and an intimate, generational understanding of stone. The real story isn't that something unexplainable happened here. It's how much human ingenuity can achieve with patience, organization, and mastery of materials. No shortcuts, no mystery required, just extraordinary skill. To be clear about where the actual science stands, because these sites attract a lot of wild speculation. We know the general methods: hammerstones, trial fitting, ramps, rope, and the middle labor system organizing the workforce. What we don't fully know: the precise logistics of moving the largest blocks across this terrain, the full extent of specialized masonry knowledge that was never written down, and whether techniques varied meaningfully from site to site in ways we haven't identified yet. Ongoing research, including 3D laser scanning of joint surfaces and experimental archaeology, where researchers physically try to replicate the techniques by hand, is slowly closing these gaps. But there's still no single, complete, start-to-finish reconstruction that every archaeologist agrees on. So next time someone tells you an ancient civilization couldn't have built this without outside help, send them here. No aliens, no lost technology, just extraordinary human patience, organized labor, and generational skill carved into stone that's still standing 5 centuries later. If this kind of deep dive into ancient engineering is your thing, subscribe,